Okay, hi everyone. Thank you for joining us for webinar part 3 on solids liquid separation with a focus on centrifugal and mechanical self-cleaning filtration. I just want to give you a little oversight as to the John Brooks Company and who we are. John Brooks has been around for over 80 years, founded in 1938. We have just over 200 employees across Canada, and something we're pretty proud of. It's a privately owned Canadian company. And we're a full-service national supplier of pumps, filtration, spray nozzles, custom skid packages, specialized valves, compressed air purification equipment, aka air dryers, heat exchangers, and pressure vessels. Our presenters today, obviously myself, Scott Thompson out of our Mississauga, Ontario office, and Sean Marvin from our Edmonton, Alberta office. Both Sean and I have 20 plus years of experience in filtration and pumping systems. And I also want to introduce today Anita Gupta, who's our manager across Canada, and Nico Floresca, who basically does everything. You'll also notice at the bottom of the page, we have a question and answer button. So if through this you have some questions, please write them in there and we'll be happy to take a look at them at the end of the presentation. And with that, I'll turn it over to you, Sean.
All right. Thank you, everyone. Again, my name is Sean Marvin. Just to let you know, I'm in Edmonton, and I woke up to our first layer of white stuff today. I'm going to actually have to get my snow brush out, so fun for us. Okay, so webinar part 3, self-cleaning, centrifugal, and mechanical cleaning filtration. Not to be mixed up with backwashable. That is actually our part 4, which will be on October 29th. So what we're talking about is solids liquid separation, removal / reduction of TSS. You know, this is going to be an educational and based on technology presentation. Scott and I are going to do our very best to have a no sales spin to this. So when I think of separation and filtration, it's only used when solving a problem. And the contaminant always dictates the method of its removal. You also only want to remove what you need to remove. Anything more, and you're just wasting money, right? Fluid analysis is obviously very important. We need to understand what it is we're working with in your process fluid. Understanding what it is we're trying to remove. Basically, we're removing TSS, which is particles. So is it hard? Is it soft? Is it deformable? Is it fibrous? Is it stringy? You know, what exactly is it, right? We'll be very interested in a TSS report, total suspended solids. We'll be very interested in a PSD, so particle size distribution by volume. That's going to give us, the range of micron sizes that's in this fluid. It could be from 1 to 50. It could be from 10 to 100, right? We're going to be very interested in those numbers, right? And most importantly, the design and selection of any equipment starts with knowing your own requirements and your design conditions, as well as site limitations. The next step is to get educated on available technologies, which we hope to cover here today. Scott's going to start off, and we're going to get right into, our topics are going to be, for technologies, is centrifugal separators, vortex or cyclone. Then we're going to get into self-cleaning mechanical. So we're going to have a bar screen, sometimes known as open channel. That's going to be more atmospheric. And then we're going to get into a blowdown basket strainer, edge type / cleaning disc, sometimes referred to as a stack disc. We're going to get into a revolving screen, and we're going to get into actuated cleaning disc. Now these bottom 4, we're going to be dealing with them in a pressure vessel. The bar screen is atmospheric. So Scott's going to lead us off.
Thanks, Sean. So we're going to start off, as Sean said, with centrifugal separators, otherwise known as cyclone separators. So essentially, what this technology does is separates solids from liquids where the specific gravity of the solids is higher than the liquid. So the higher the specific gravity, the more efficient this type of unit is going to be. The one thing to watch for with these, though, because they're based on specific gravity, lighter solids are not going to be separated with this. So if that's what you're looking at, there's different technologies for that, and Sean will touch base on those in a little bit. These separators can go down to 44 to 74 micron. There is a slide that I'll explain that a little bit further, a couple slides from now. Now, this unit with a single pass has a TSS range between 1 and 5,000 parts per million.
I'd also like to add, Scott, if you were to run 2 of these units in series, you could push that TSS range to 8,000 to 10,000 ppms. If you were to run 3 of these units in series, you could push that to that 15 to 20,000 ppms. The other thing that we should point out here is, you know, if this is to be considered a technology that might be of interest to you, a real simple test is grab some of your fluid, put it in a sample jar, a water jug, shake it up, set it on your desk, and watch it. If it settles out to the bottom in 3 to 4 minutes, there's a good chance this technology will work. If it doesn't and it stays floating, then it's just too light and it's not going to. This technology would not be something you would want to consider.
Great point. Thanks, Sean.
Here we go.
Oh, okay. So if you watch this video, here's basically how this technology works is through centrifugal force. So if we just pretend that these kids are the heavy particulate, essentially this is how this is working. So, and one of the very best things or the nicest things about this, there's no moving parts to wear out or replace. There's no backwashing or other routine maintenance and downtime. In fact, a lot of people that have these forget they have them for a number of years, so it's really nice. Now, one thing to remember though, when you're designing your system, these do need a steady pressure loss across the unit to create that centrifugal force, anywhere between 3 and 12 PSI. They're very easily automated and a fantastic pre-filter. All right, Sean, we'll go to the next slide here. Okay, so what we have here is basically a diagram or a picture of one of the vertical units. So they come vertical or horizontal. Where Sean's pointer is, basically at the top left, that's your inlet or dirty fluid. At the very top is your outlet, clean fluid, and at the bottom left is your solids purge area. So if we go back up to the inlet, so the dirty fluid's coming in that top chamber, and you'll see that yellow arrow right there. So basically what's happening is there's those internal tangential slots. What they're doing is accelerating the fluid and particulate, creating a vortex that then pulls that fluid and particulate down into that separation barrel or chamber, if you will, just below that top section. So what's that's doing now is creating that centrifugal force. So if you picture those kids, they're now flying from the middle to the outside of that barrel, working their way down to, if you notice on the bottom, there's a separation plate just above the purge chamber. So that's creating a low pressure area underneath, helping those solids fall down into the purge chamber where that can be expelled. So in essence, that is the technology and how this is working. Okay, so now this slide, we mentioned the 44 to 74 micron removal. So if we just take a look at steel with a specific gravity of 7.8 in the 20 to 40 micron range, so if we look at the left bar chart, you'll see the light blue or purple, if you will, 20 to 40 micron, specific gravity 7.5. So if you go up with that type of material, you're going to have about an 80% efficiency removal rating. If you bump up to between 40 and 74, that takes up to 95%. So if your materials or any of these are heavy specific gravity, steel, aluminum, sand, these units work exceptionally well in that type of material. One of the big industries for us is steel. So metal flake, metal particulate slag. These units are widely used, accepted, and work extremely well. Sean, do you have another example?
Yeah, I've done quite a few applications. River water. Anybody pulling from the river to bring water into your plant, even municipal, your first set of your first line of defense should be to put it through one of these separators. Works awesome on the sand. And again, you think about anyone that pulls from the river, you have seasonal conditions, you have a lot of upset conditions. So for example, when it rains, river gets very agitated and you get that sand and silt. So these units is this perfect application for them. Is anyone pulling from the river or some sort of fresh water. All right. Before we go any further, I want to address an equipment process flow diagrams to get us kind of all on the same page with what this system's going to look like. So what we're going to be talking about is some different technologies here, but what's going to be common amongst all these technologies is one, we're going to have our inlet dirty fluid, right? And it's coming in. We're going to have our technology, which is our filtration. And then we're going to have our outlet, which is going to be our clean fluid, right? That's pretty straightforward. Now, something that might be new for some of you is we're going to have a purge waste stream. This purge waste stream, this is the contaminant, right? And this purge waste stream, it needs to be piped to an atmospheric tank, pit, pond, something like that. We can't be pumping into pressure because we are relying on inlet pressure to do our cleaning filtration, which I'll get to in a moment. So just bear this in mind. This third purge waste chamber is something you need to be able to deal with, and where is it going to go, and what are you going to do with this? Now, getting back to this, when we have our inlet, right, something that you need to consider on your piping design is we should have a gauge port, we should have a sampling port, and we should have, or we could have the need for a DP transmitter, and that's both for the inlet and the outlet. Now, I say gauges because we're going to be playing with differentials. So how do we know we have a differential? We need gauges on both inlet and outlet. I suggest we need sampling ports on the inlet and outlet because with any filtration, to make sure you're getting the level of filtration that you require, right? You need to grab an outlet and an inlet sample. You need to take them to the lab, or maybe you have in-house capabilities. You need to look at it in some way to see if you're getting the level of filtration that is required, right? Again, I said earlier, we're always curious about TSS, particle size distribution, and total suspended solids, and PSD, particle size distribution. Comparing those two results is what we need to see if we're getting the reduction or we're getting down to the micron size that you require. Now, on the purge system, we will need some sort of purge control system. Now, this could be as simple as a ball valve that you open manually and you do a purge. And by purge, I mean we're going to open this up, and again, this technology, we're going to have purge out the dirty side of this waste stream. Now, again, some of these systems, again, a manual ball valve is very basic. You could get into some sort of air actuated or electric actuated control valve. Not a control valve, an actuator. That is then going to talk to probably a control panel. Again, when you're looking at this technology, I'm going to assume that we're looking at some level of automation because we're looking to make life easier for us, and we're not wanting to change out, say, disposable bags or cartridges, or have something plug and you've got to take it down to clean it out, right? So this control panel to our purge control system, what is it going to want to control? We're going to want to control how often does it open, and when it does open, how long does it stay open for? So for example, the application could say we could have it set up on a timer, and the timer says we need to do a purge every 30 minutes, and when we do our purge, we're going to open up for 1 second. Or we could have it tied to pressure transmitters, which are talking to the control panel, which could be talking to the technology, but they're for sure talking to this purge control system, and they are saying, okay, we see a delta pressure of 15 psi or maybe 6 to 8 psi, and we need to do a purge. And when we do our purge, again, we want to open up for 1 to 2 seconds. Again, that is going to be depending upon what this purge waste stream piping looks like. So this is an important slide for just getting, you know, a basic understanding of what we're going to be requiring moving forward. I think I've covered everything on that slide. Yep. Okay. So moving along, we're going to talk about our media material technology that we have available for us. So one of the most common medias that you're going to find that we use in the mechanical world is slotted wedge wire. Again, very common, it's very durable, it's very strong, and it's good for a wide range of applications, right? TSS. It also gives us a smooth surface. Again, in this mechanical cleaning, some of this technology, we're going to be scraping this surface. So this is obviously showing a flow path of outside to in, where we could scrape the outside of the screen, the wedge wire, or we could have a flow path of inside to out, where, you know, these bars, supporting bars, would actually be on the outside. So, and I will just show you our range. So our range is obviously 15 to 1600 microns. I put 5 micron in brackets because that's based on theory, but when I go to the next slide, you're going to see that 5 micron is not realistic when you look at our percentage in your open area. 15 micron is really tight. Like look at our slot, right? 0.0006. So that's 2% open. So, you know, again, anything smaller, the screens just don't flow any fluid, right? So this just shows you our range of sizes. The next one I wanted to touch on is, you know, perforated screens with optional mesh lining. If any of you are familiar with basket strainers, right? Basket strainers, you know, obviously we use a perf material. You want something finer, you'll mesh line it, and you want something finer than that, then you tend to get into the a micron size, right? But you know, most common is 1/8 perfs. That's standard on basket strainers. We have options down to 132, I guess it is. And then we get into, you know, mesh. So when I think of mesh, I think of, you know, your screen door, you know, the screen material, right? And that's getting even finer, but that doesn't get even, that's not as fine as, say, micron sizes, right? So these are just the media that we have to work with in the mechanical world. So one thing I also want to touch on is our fluid flow direction. So some of this technology will be flowing inside to out. Some of this technology we're going to be flowing outside to in. Sorry guys, there we go. Efficiencies. So in this, you know, this metal world of media, we're going to be, you know, playing in that nominal to absolute. So, you know, nominal can mean 50% to absolute meaning 99.9. So just to give you an idea of the efficiencies that we're looking at. Now, the other thing I want to bring up is pressure drop. So clean pressure drop, again, with properly sized equipment, you know, with clean media, we're looking for a 1 to 2 psi-d. That's pretty common in most filtration systems, right? It's the same thing with you know, metal mechanical type filtration, right? The recommended cleanout can vary depending upon the equipment, but you know, generally you're looking at that 10 to 15 psi-d, and you know, some of this equipment will get you down to that 6 to 8 psi-d, right? So just numbers that we need to be aware of. Now, I'm also going to bring up system pressure drop. And what I'm getting at here is our outlet piping design and controls. again, I just want to bring this to your attention that when you set up your systems, right, you need to make sure that whatever your system pressure drop, you know, how you set up, you're making sure you're satisfying this filtration equipment, because all this equipment we're talking about works off a delta P, right? So we need to build a delta P. We need to know what that delta P is so that we can do some sort of a mechanical cleaning process. Where I've seen customers run into trouble, or systems run into trouble, is you take your outlet piping design and you look at the end of that pipeline, that piece of piping, and it's going to go into maybe a tank or a pit or a pond. Sometimes you'll see a control valve there that's talking to a PLC, and the PLC is talking to tank level, and depending upon the tank level, it's telling that control valve how much to open and close, which then can cause issues back to our piece of equipment, because we're opening and closing and we're changing back pressure, and it's now causing the unit some issues. So I just want to bring that to your attention as something I want that you need to be aware of when you're looking at designing your systems. So now we're going to let Scott talk to us about bar screens. And again, this was one of the ones that is not a pressure vessel. This is in the atmospheric world. Okay, Scott.
Great, thanks, Sean. So as Sean said, these units basically flow through. They're non-pressurized. So if you see Sean's laser pointer in this diagram, your inlet or dirty fluids basically coming through a series of bars to your outlet on the clean side to the right. And in this case, your purge waste or your purge chute is at the top of this unit. So basically what's happening here is there's a series of parallel wedge bars with equal spacing through the outlet. So typical sizing in this is 1 millimeter to 6 millimeter spacing. The particulate is then trapped. You'll see Sean's laser pointer right on the bars there. It's trapped on the influent side of the bars and then grabbed by a series of rakes. You'll see that chain and wheel. So these rakes have teeth that go in between the bar spacing, grab the particulate, raising it up. Sean's at another rake right there. Up top, there's a scraper that then scrapes the particulate or material off down into your purge chute, into your purge waste area. And essentially that's it. That's how these units work. Now, the really nice thing about these, very, very low maintenance, extremely long life. You can do minimal to exceptionally high flows and very, very high solids. You'll normally see these in wastewater plants, but one of the neat applications I had was actually fish scale. So I didn't know that fish scale, when it got into a system, destroyed pumps and seals and pipes and valves. So we put one of these in for them with the 1 millimeter spacing, and they're very, very happy with it. So these are extremely effective. And I think, Sean, you've got a pretty good application as well where it's worked.
Yes, we had a customer, I'm going to call it was in the sump. So, you know, in the sump was, you know, basically in the floor, and everything got, you know, pushed into the sump. So, you know, sumps are just full of heavy solids, dirt, you know, this was oil recycling. So there's just all kinds of crap in there. And, you know, they put this in there to, you know, they wanted to recycle the water, to reuse the water. And so they put one of these in there to remove the heavy solids, right? And again, once it got set up, it just runs like it's a maintenance-free item, right? And you know, it was a great application for, you know, any kind of solids in it. For them, them having to clean out that sump, which was a horrible annual job where you had to bring in a vac truck and then you had to get guys in there in the pit with shovels, right? It was nasty. All right, now we're going to talk about blowdown basket strainers. So we're getting into pressure vessels, right? Simple design, you know, where solids are heavy and well defined. Screen flow path is, our flow path is inside to out. Solids are accumulated in the inside of the screen and the bottom of the vessel. The differential pressure between the operating pressure, inlet, and the purge system, atmospheric, evacuates the contaminants from the collection chamber. So we have a minimal process fluid loss doing purging. There is what I would call a flow reduction during this purge. This is all done without shutting down the system. TSS range, you would be playing in that 200 to 400 ppms, right? So again, our dirty fluids coming in, we're going through our screen. Now again, I'm sure many of you have seen a basket strainer, right? Well, this is basically, it's a fancy basket strainer. We've got our outlet, but this basket does not have a bottom to it. It's like a cylinder shape. So that allows our solids to, collect in a bottom chamber, and we've got a sealing point on the top and bottom. So, all the dirty side is in the inside of the screen, and anything that flows on the outside of the screen is our clean. So again, we talked about a purge waste. Again, I said before in that other slide, it could be as simple as a manual ball valve, right, that you open. It could be, as automated as, hey, we got a control panel, we've got DP switches, we see a delta, we build up a DP of 15 PSID, and we do a purge, and based on our solids, and right, we open that up for 1 second, 2 seconds, and we do a flush, right? Very simple. And these are coming in a wide variety of sizes, right? I would consider these probably more on the coarse side when you get into where these might get used. And again, application-wise, many applications, right? Any dirty fluids, probably more, water-related type products, right? Dirty water, but because again, you're going to be using either a perforated basket or a perforated basket with a mesh lining, or you're going to go to wedge wire, right? The next technology we're going to talk about is what we call edge type cleaning blades. So an edge type filter is an assembly of which is going to be turned into a cartridge of wheel shaped discs, spacers, and cleaning blades stacked on a rotatable shaft. Each filter disc is separated by a spacer. So the spacer, thickness of the spacer, determines the micron size of the of this cartridge, and we have a range from 38 to 760 micron. When the cartridge is rotated, the cleaning blades mechanically comb out the filter slots to their full depth. So this is going to be this space right here, right? And this is our cleaning blade, right? So these are stationary, and these filter discs are going to be what rotate. So our flow path is going to be outside to in, and the TSS range these are going to play in is going to be that 400 to 500 ppms, right? And they're going to be stacked. So there'll be many stacks. Let me show you another picture here. So this is a very basic design, right? So again, we have our fluid, our dirty fluid coming in. We've got what we talked about being this cartridge assembly, right? So we're flowing outside to in, right? We're going through the inside of the cartridge. Here's our clean fluid coming out, and this is our clean fluid. Our debris is all stuck on is on the outside of the cartridge. We've got our cleaning blades that are scraping, and it drops the debris down. And again, we're going to have a purge waste stream that is going to need to go somewhere. Now, this is a very simple, basic. It's got a little T handle, which is you're just going to manually turn this. This is a small applications. I just want to, there's a good picture to show you how they work, right? If I show you the next picture, right? This is, some other applications. This is a cartridge, so this is going to be, like what we would call a 3 stack. So this is probably 24 inches in height. Diameter wise, what we're going to have available to us is 2 1/4, 4 1/2 inch, 5 3/4 inches, 7 3/4 inches, right? And then the lengths of these stacks will be anywhere between 5 and 8. So you'll make up these cartridge assemblies. And then, in some of these applications, the bigger the applications, well, you just need more of these. So, here's a picture of a vessel where you can see we've got an electric motor and a gearbox, and these the cartridge rotates at 1 RPM. So it's a slow rotation, right? So, I'm looking at this application where this is going to be continuous. It's just going to be continually rotating, continually cleaning. So there's no flow interruption, right, for the unit. And there's no flow interruption doing purging, right? Because it's, it's just by the surface area, right? This is all metal construction. So, these are gonna like hot fluids, so standard, they're good for 250 degrees F. Special, we can get up to 500 degrees F. So they're gonna like viscous fluids. Again, when we're constantly cleaning it by turning our cartridge assembly, right? So your cleaning DP, is typically, as we're continuing cleaning it, down to that 3 psi-d, right? So some applications for this type of technology is it's going to like, gear oil, grease, oil, diesel, hydraulic oil, glycol, vegetable oil, right? Adhesives, glues, coatings. It's not going to be a big fan of water-like products just because, water-like, they tend to get some scaling on there and you've got these thin discs. So, it has its place, right? So that is the edge type cleaning blades. Now we're going to talk about revolving screens. So revolving screen, liquid enters the vessel and flows through the element from outside to in. Debris is collected on the outside of the element. And typically we're talking about wedge wire screens, right? Because we want that surface, that smooth surface for scraping. And we scrape the blade by the rotation of the element. So the element rotates. So similar to the edge type, where we're rotating the cartridge here, we have the element that rotates. And then we have our scraping blade, which is stationary. So again, this is just a manual, ratchet type assembly where you could manually turn the screen to scrape it. And when you scraped it, you would be knocking the debris down into the sump, right? Then you would have some sort of purge waste stream, right? So dirty fluid in, we're flowing outside in. Our flow path, just like that edge type, is back up through the center of our rotating screen, out the outlet, and that's our clean side. We are going to have no flow interruption during purging, right? Because of the continuous operation of the filtering. Our range is going to be between 50 and 100, between 50 and 1000 micron. Again, minimal product loss during purging, right? And TSS, I would say we can handle up to 200 ppms, right? Let me show you another picture here. These typically what I've seen of them, they're more in an inline configuration. So if you looked at one of these, again, our inlet, dirty fluid, outlet, clean fluid, here's going to be our purge system. Again, when we look at this type of technology, we're talking a little more automation. We're going to have a control panel that's going to be talking to the motor, telling it, again, we'll have a gearbox here, but we can rotate continuously, or we could say we could rotate every hour for 5 minutes, right? It all depends on how we want to set it up. We've got a differential switch, so to tell us when we need to do a purge, right? So this control panel, we can set it up any number of ways based on your application and what we're trying to remove, right? So here's a couple of pictures of what an actual unit would look like. Inlet, outlet, there is our motor, we've got our control panel, our purge system, right? This one here, if you can see, we've got 2 motors on here. So again, this would be for a bigger, higher flow type application. We would have 2 rotating screens inside this unit. So again, we would have an inlet, outlet, purge, control panel. Pretty simple, right? Now, some applications for this will be, this wedge wire is going to be, it's going to love water, dirty fluids, wastewater, recycle water. Really, wedge wire is so universal, right? So it can be used in many different applications, right? I actually had a customer buy this, and they were filtering hemp. So we had a loop system, and then they had set up 2 of these units, and what they wanted was the purge stream. So they had one set up for 50 micron, one set up for 100 micron, and they just, what they pulled off at the different, out of the purge, was actually what they wanted. So that was just, that's just an example of, right, applications. All right, we're going to let Scott have a turn now and talk about cleaning disc style.
Okay, great. Thanks, Sean. So what we have here is a picture of, like Sean said, the cleaning disc style of unit. So I'll just go through the parts. So 1, you've got your vessel or housing. 2, you've got your wedge wire screen. 3 at the top left is your inlet, and 4 at the bottom left is your outlet. So it's a top down, inside to out flow. Now, the big thing with this, where I think the big thing with this is this cleaning disc. Sean, if you could just jump ahead 1 screen. So this is a picture of the actual cleaning disc. Now this material comes, a variety of materials for chemical compatibility. But what you see here, this unit is actually spring loaded. So when it's actuated and goes up and down the wedge wire screen, it's a friction fit. It is actually scraping the particulate off of that screen. So Sean, if we just go back 1 slide there. So I'll get into the actuation, but basically that disc, this one's on that shaft, basically scraping up and down that wedge wire screen, eventually forcing the material off the screen and down into your bottom chamber, your waste chamber. Now the TSS limit for these is between 2 and 500 micron range, 15 micron to 1125. Now, one of the really nice things, there's very minimal product loss, continuous flow. But to continue on, as the material goes down, it's basically purged out, as Sean mentioned before. So with this style, there's 3 types of actuation. So on the left, you'll see a twin actuated unit, cylinders. You can get it in single and double. Like I say, this is the most common, but with this type of unit, you need 60 to 80 pounds of air pressure to actuate the cylinders driving that shaft up and down. And that shaft does go through the top of the housing, so there is a sealing requirement, obviously, for this one. The middle unit that you'll see there is a motor driven. So if you don't have compressed air, this is a good option. They also get used, if you a lot of fibrous materials, they seem to work really well with that type of application. And on the far right, nice unit as well. Now that's a magnetically coupled disc on that shaft. Now, the one thing to keep in mind, you still do need the 60 to 80 PSI air pressure to activate that disc going up and down the shaft. But if you have a class 1 div 1 application or a liquid that you don't want to get to atmosphere, it's a good option to look at. The magnet's only like up to about 180 degrees Fahrenheit, but if your application fits, very nice unit, something to take a look at. Now, another nice thing about these units, one of the applications we have, they handle viscous materials really well, and the one that keeps coming to mind, grease. So if you picture thick grease like you would put into bearings on a Caterpillar or a big John Deere or Volvo heavy equipment, we have it in an application like that, filtering that. That being said, it's heated because of how viscous it is, but it's working really well for them. I think, Sean, you've got some pretty good applications as well.
Actually, yes. So, I've heard of these. You guys out east told me chocolate, used in chocolate,
Yep.
paints, coatings, but, dirty fluids, and water-like fluids. I'll just add, so, back on that slide with that flow diagram, these units will definitely have a control panel, and that control panel will control 2 things. One, this stroking of the disc. So we'll be able to control with that control panel how often we want to stroke the disc. So it'll just go stroke the disc, and we can say we can have it, going down and then going back up. So we could have what I would call continuous. So every 30 seconds, we're stroking the disc to keep it from building up a differential on the ID of the screen. Then we could have it set up so it strokes the disc every 5 minutes or every 30 minutes. Again, it's depending upon your application, right? Then the other side of it is, so again, that control panel will control this purge system. So that purge system, again, the control panel could be off a timer that says, okay, every 1 hour we want to do a purge and we're going to do a 1 second purge, right? So the nice thing about this is because the control panel, we can control, the stroking of keeping our screen clean and how often to purge. This is a unit that we want it to run with that 3 to 5 psi clean pressure drop. And when we're seeing between 6 and 8, we want to do a purge, right? So we don't want to let our solids build up on the ID of the screen, right? And just different technologies, right? So these are very used in many different applications because of how easy they are to set up. Yeah, so that's, and one more slide here.
Okay, great. So I know Sean and I have been talking about, mechanically screened or mechanically actuated filtration, but what this slide is, just to let you know that myself, Sean, our whole group in John Brooks, we deal with all kinds of filtration. And what this is, Anita's put this together, and it's a real nice way to focus in on, the technologies to look at for your application. So for instance, if it's large particulate, 800 micron to 1 inch, you'll see down the left, type of filter, strainer, manual self-cleaning. If you look over to the far right at 0.01 micron, you may want to look at reverse osmosis and everything in between. So it's just a quick guide, something to look at, and we can hone in on your application. And again, like I say, the whole group at John Brooks, very knowledgeable and happy to talk to you about any applications you have. And I would say with that, I guess, Nico, do we have any questions or?
Yes, yep, we do. One of the first questions is regarding the TSS and river water. So the question is, what's the typical river water TSS versus surface lake or pond water?
I'll take this one.
Okay.
I've had quite a bit dealings in river water, and river water can vary. Again, last year, we had a lot of rain in Edmonton, and I was working with a customer, and anywhere from a calm day to, again, it's also seasonal. So you think about when the ice melts, it tends to agitate the river, and the turbidity goes up, and the water kind of turns brown, right? And you get all those fine sand and silt. So and then you have the days that it rains. So we can be playing with 5 ppms to 3,000 ppms. And I've seen some water test reports where again, in a matter of 24 hours, we went from, 1,000 ppm to 2,500 ppms, right? So it varies, and it's seasonal, right? It really depends on the weather, right? Now that's river. A lake, right? If you're pulling from a lake, well, again, how agitated does it get? During calm weather, your TSS level will be relatively low. After a big rain, it's going to get all agitated, right? So it really varies, right? So if you're ever dealing with river or lake water applications, you need to do monthly testing. You need some history, and you're probably most interested in it after it rains or when it's agitated, because that's going to be the worst case scenario, right?
Great, thank you, Sean. Another one question, it's actually pertaining to the strainer that you were showing that had the open bottom basket. So the question is, can you crack open a purge valve for the blow down basket? If yes, what degree do you recommend, and what would be the pressure drop be across the filter?
Okay. I'll take that one too. So when I think of that scenario, that's actually real. So what we can, when you have what we would call continuous bleed. So, Scott talked about centrifugal separators. When you get into those applications, when you're playing in that 3,000 to 5,000 ppm world, that's a lot of solids. So, there you'll have you'll want to set that unit up with a continuous bleed. And by continuous bleed, we're probably, I've heard anywhere from 3 to 5%. I've heard, 5 to 10% of your flow rate, right? So that would be the same thing with, that blowdown basket strainer, right? Same scenario, right? If your TSS level is that high, well, you've got to get those solids out of there, because if you don't get those solids out of there, they just build up, and they'll plug up the screen, and they'll just fit the total inside of that chamber will just fill up with solids. So yes, that's very common. Or if you looked at it where you had some level of automation with DP switches, if your TS level gets too high, well, then your unit is just nothing but going into purge after purge after purge because of a high TSS environment. So again, when we look at these applications, that's why we're very interested in understanding your contaminants, your TSS, your particle size distribution, because we have those different scenarios. I always look at filtration is, in this application, are we challenged with removing 1 pound of solids an hour, 10 pounds an hour, 100 pounds an hour, 1,000 pounds an hour, right? What are we dealing with?
Mm-hmm. Thank you, Sean. That's good. A question now is pertaining to the type of contaminants. So how do you handle fine solids that are attached to paraffins or waxes?
That would sound to me, if that was a continuous operation and you're able to keep it relatively, let's say, warm, I think that looks like the cleaning disc style of filter that could help out. Now, with that being said, the whole group, we like to actually, well, COVID's a little bit different, but we used to like to come to site quite a lot, and we could perform tests, we could look at it, we could grab samples. We have demo units that we could bring out for trials, but that sounds like the perfect application for a cleaning disc style to me.
Scott, so if I might add to this,
yeah.
Now when we say fine solids attached to paraffin or wax, so there is what Scott has just replied, that actually removing solids from waxes itself. Scott, remember the company who makes candles out in Brantford, like we were using this mechanical cleaning. So that's one. Then another type of applications could have been, you have solids in addition to asphaltene and all that, the sticky substance. That's a different type of challenge we have. So I think it depends on, are we trying to get rid of all those solids as well as waxes? Then it's a different technology. Or are we interested in keeping those paraffin waxes and only remove solids? Then we look at a different technology. So I think we can talk more into detail on that, depending on what the details of the application is.
Yeah, if it's deformable, it's a lot more challenging.
Yeah.
Because it changes shape, and you could, depending upon what your filter media is, right? It could get pushed through it because it deforms.
Yeah.
There's quite a bit of questions flowing in now. So this one is pertaining to the self-cleaning strainers. Do mechanical self-cleaning strainers have a reliable operation cycle, or does downtime and maintenance need to be factored into the production cycle?
I mean, I can try and field that question. I would say if the proper unit's put in and in the proper situation, it's set up properly, honestly, these units, very, very little maintenance. I mean, we sit there and tell everybody once a year, depending on the technology, take a look, see what's going on. Most people don't do that, so it's every 3 years we get a call, something's gone wrong. Then you get the odd application where it might have been the wrong technology, or possibly not put in properly, and then there's some issues with that. But that's where, you know, the whole team comes in. That's why we like to visit, or at least I guess now we have Zoom meetings. We'll still come visit. Take a look at everything, including your piping, your complete system, your particulate, everything, and try and come up with the absolute best solution for your application. We try really, really hard to make sure that you get something that makes you happy. We don't want to sell you something where it's just going to be a problem. That doesn't work for anybody. But it's a tricky question, that one.
Mhm.
Now, Scott, since the question is about the technology,
Yeah.
is mechanical cleaning filter reliable? I mean, it's like asking, oh, is car a reliable mode of transportation? It's the technology. Yes, technology is reliable, but every technology works based on how robust the mechanism is put into it, right? You can have a mechanically cleaning filter manufactured by a manufacturer who has 100 years of experience versus somebody who just went into in 1 year and selling all across the globe. So those are the little things that makes a difference. But is technology reliable? Definitely. We have seen it in very, very like coarse applications and municipal mining applications. We've seen them working in very, different environment. So technology as such is very reliable.
Yeah.
And it's also matching up the right technology. Like you were talking about screen media, right? Some media works better. Again, it's understanding your particulate that we're trying to remove, right? And matching it up with the right type of media that we're going to use to remove it, right?
Yeah. Nico, there's a question, if you don't mind, if I'm going to take the river water filtration for pre-filtering.
Yes, I was saving that. Yep.
Yeah. So there's a question here. It's very close to my previous background. River water filtration for pre-filtering of UF and RO membrane units, currently using 50 micron screen filters and encountering rapid plugging in UF filter suspecting LG fouling. Okay, so let me start by saying the system is not entirely ideal. An RO membrane definitely needs much finer filtration than 50 micron. An RO membrane, every RO membrane system must have a 5 micron pre-filter, good pre-filter. So assuming it's there, and however, there's still a 50 micron pre-filtration, either it's a UF or RO. Now, if the UF filters are still plugging, that is not just due to the pre-filter of 50 micron not working very well. Because the UF membranes can plug because of the high BOD content coming in, high TOC coming in. That makes your UF membrane or the RO membrane that we use the word fouling. A lot more fouling is happening and you need to do a lot more regeneration. So I think that needs to be looked into a lot more detail of what is causing the fouling. And to answer, yes, LG could very well be an issue. And there are not very many self-cleaning filters out there which remove LG. Going after that, we will, our next presentation, which is on 29th, we will be talking about all self-cleaning, back-washable filtration, and we will be discussing one technology in particular that works for LG removal.
Great, thank you, Anita. And this ties well into the river water discussion as well, but this time it's pertaining to heat exchangers. So the question is, I want to filter river water going to plate heat exchangers. What technology would be best to prevent sediment settling and fouling of the plates?
Do you have again, what do we know? I guess my first question is, I want to know what micron size are we thinking that you want to filter down to, right? Are we thinking like 25 micron? Are we thinking, 50 micron, right? So that would be one of my first questions, but there's, if it could be a separator, right? Centrifugal separator that could do the job. right? We have models that get down to 44 micron, and that could be all that's be required. Depending upon the micron size that of the particles that you're wanting to remove, as well as, again, I hear river water, I think, okay, we have seasonal conditions, and when the winter is the best conditions, summer and rain is the worst. So you got to plan for the summer and the rain, because those are the worst conditions. So you could look at a number of technologies depending upon what that micron rating retention is that you're looking for, right? I think when I think of heat exchangers, I'm thinking if you, pre-filter down to 50 micron, you would be in pretty good shape, right? So we would have a number of technologies.
Yeah, and sorry, Sean. And usually, if you have the heat exchanger already, or you don't, whoever's designing it, whether it's our group with APV or whatever, they'll be able to tell you what they want you to filter down to. Then we could take a look at your application and see what your worst case scenario is, and try and come up with the best technology to help with that. But it can be done. It's not a problem. It's just diving a little bit deeper into that one on our side.
Okay, thank you. Yeah, that's definitely something that another thing that needs to be considered, however, is you mentioned, Sean, multiple technologies. For river water, it's something that we do recommend oftentimes, that it's the staged filtration. A single technology often will not be able to address kind of your filtration requirements. So we want to offer something that's in a staged approach, so it's not undersized or oversized. Now, another question is pertaining to the centrifugal separators. So one of the questions is, what are the important criteria in fluid to decide for selection of centrifugal separator or dust cleaning filters?
Flow, TSS is a big one. Specific to centrifugal separators, it's specific gravity. I mean, that's really the one that's going to come into play. I mean, for instance, I was called out to a plant, they tomatoes. So they're processing tomatoes. I was a little bit hesitant, but I took out the demo unit anyway. There's so much silt in there. It took out the sand, no problem, but the sand was only maybe 5% of what they had in there. So the water went in dark brown and came out dark brown. It just wasn't heavy enough to for that unit specifically to work properly. Now the cleaning disc technology, obviously you can get down to a lot finer particulate, depending on what it is. But I think the big trick here is every technology is different and every process is different. And that's why we really try and come out and work with you, take a look, get some samples, find out what it is. It's deformable, whether it's solid, whether it's based on weight. I mean, all these things make a huge difference into picking the right technology. Even temperature, chemical compatibility, obviously, are huge factors. So, I mean, I know it sounds probably like we're talking in circles, but everybody's application is so different. It lends itself to different technologies all the time. But centrifugal separators, it's definitely that weight. Sean talked about the mason jar. That's a really good first step you can do on your own in minutes. See if it settles out. Then if it does, let's take a look. Be a great technology.
It also depends, again, I touched on, water analysis, right? A TSS report and a particle size distribution report, they have a lot of meaning because they're going to tell us what micron sizes we're working with, and then the percentage of them to TSS. So it gives us an idea of, how many solids we're dealing with, right? Because, we have different technologies. So which is the best way to go? If you have an application that's only 100 ppm, well, I would go this way. If you have an application where we're playing at 500 ppms, I would go this way because, again, I look at these systems as, are we challenged with removing 1 pound an hour, 10 pounds an hour, 100 pounds an hour, 1,000 pounds an hour, right? That has a lot of bearing on the type of equipment and or the different stages we need to build you a system to remove the contaminants, right? But
Okay.
what else you got, Nico?
Hopefully that answers the question. And then one question is specific for application. What is the separation mechanism for sugar to make crystal clear? So it is something that perhaps Scott, I believe you had done a startup at some point with a sugar company.
Also, okay, that's a trick question too, because Anita and I have done a bunch of sugar applications. We have used, now I'm not going to say this is right, but we've used the cleaning disc technology depending where it is in the plant. Now we have had people trying to remove sugars from liquids, and that really starts falling into Anita's skill set with reverse osmosis, high pressure, all that kind of stuff. Honestly, we'd need to know more about that application and what you're trying to do and where the sugar's at in the process. But we've done it. We've done a number of applications with the big guys. You'd know the name if we said it. But if it's removing sugars from a liquid, I'd grab Anita and bring her along. So
Scott, I think what this person is asking for is this best separation mechanism for sugar to make crystallite. You're right. The filtration is actually just one step off in the big scheme of things. Filtration will not separate up to the level that to make crystallized sugar, because there's a distillation step comes in it. There is an evaporation step. There's a multiple other steps involved in the whole separation mechanism process. But filtration is one step. And as Sean and Scott had started at the beginning, what we were discussing today is the solids and liquid separation mechanism by using a centrifugal force or a barrier filters of mechanical. So I don't know if this was not really the topic for today.
Yeah. So if it's application related questions, feel free to send either Scott, Sean, or myself or Anita an email, and we'll be happy to lend our assistance. But out of respect of everyone's time, Scott, if you want to do the fairly well.
Okay. So I'll just thank everyone for taking the time to join us. We appreciate it. I hope you learned something. I just want to also let you know that we have some trial test pilot rental equipment available. So, again, we can talk about it, and because again, some of it is you got to test this technology, because again, different technology works better for, different applications or different particulates. So we have a lot of this technology available to come to site with and do site testing with you. So please feel free to get in contact with us, and I got no problems going to site, and let's just talk about your application. We have another webinar on part 4, solids liquid separation, back washable self-cleaning surface on depth filters. That's on October 29th. So that'll kind of round out this topic. So please join us. Also, for those of you that are looking for a certification of completion, those are available as well. And if you want a recording of the presentation, it's available as well. So thank you very much.
Just one more note. Thanks, everybody. And as Sean just hit on, if you're okay with it, we are happy to still come to site or video, whatever you're comfortable with. We're happy to do that and help with your applications.
All right. Thank you very much. And we'll wrap it up. Yes. So thank you. And if there's any remaining questions, there were a number that were not answered, we'll send it in the follow-up email along with the link of the YouTube video.
And like for signing up for our next webinar, people can go on our website, go under events section, and there's a calendar. And it's not just we're doing educational webinars on filtration topics. There's a lot of topics related to our pumps, pressure vessels. You could also go to the past webinars and listen to recordings. And if you want a presentation in PDF or something, we're more than happy to send it to you. Just send us a quick email and we'll be happy to do it. And we'll be happy to also present a webinar that is pertaining to your specific application. If anybody wants to have a group of 5, 10, 15, 20 people, yeah, you can have a personalized webinar.
Yep. All right. Thank you, everyone. We're signing out now. Thank you.
Thanks, everyone.
Thank you.